Hi, welcome back to LeetCode. Today we discuss LeetCode problem 670 maximum swipe. So the problem stated that you are given an integer num. You can swipe 2 digits at most once to get the maximum valued number. Return the maximum valued number you can get. So this is the example. Example is 2736. So I can swipe maximum 2 number. Means I can call the swipe function only once maximum. It can be 0 or 1. So this is your input number. So what is the maximum number can I get actually? So if I swipe suppose this 3 and 6, suppose this 2 digit 3 and 6, so then the number will be 2763. This is actually greater than this input number, correct? So this can be one possible answer. Can I get maximum greater than this number 2763? Can I swipe this number? If I swipe 2637, it is actually smaller than, so it is better than don't call the swipe function, correct? Now can I call this function swipe function 2 and 6? If I want to swipe this 2 digit 2 and 6, then the number will be 6732. Okay, this is actually better. This is the better, right? Because it is greater than all of this number I have seen till now. Now can I swipe any other number, any other digit? Yes, I can swipe this 2 digit, then number will 7236. Okay, this is also better than this number, previous number, correct? So this is our answer till now. Can I swipe any other digit? 3 and 2? Yes, 3 and 2 I can swipe this 3726. This is actually okay, not good actually. It is smaller than the number I have seen till now, maximum number, correct? So this is our answer 7236, correct? So when actually, like for this example 9973, if I swipe this, if I place this 9, if I swipe this and place at the end, so then what will be the number? 3979, correct? So this is actually smaller than this input number, correct? So this is better than, this is better to call, don't call that swipe function. So this is actually, this will be our answer 9973. Suppose our input number is 9989. Okay, so I have to place maximum number at the front, correct? So if I swipe this function, does it matter? Our number will change? No, number will be again 9989. If I swipe these two number 99, again it will be 9989. Number is same. If I swipe these 2 digit, then number will be 9998, correct? This is a better. So this will be our answer 9998. Now we have to first of all, one observation, this place maximum digit value at the left, correct? Suppose this is our number 1 2 3 4, then this is your example. Then when you will get the maximum value, if I place this maximum digit, maximum, what is the maximum digit in this number? 4. So if I place this 4, so if I have to place this 4, then 1 I will swipe back 4 2 3 1. So this will be our answer. This is the largest possible. So first of all, we have to try to place the maximum value digit at the front or the left side, correct? This is one clear. So and this is one observation. Now suppose this is a same 9989. This is the one situation. Like here actually you can check at the front, both are actually same 9989. What is the maximum digit? 9. So if we place, I have already shown that if I place swipe this 2 digit, doesn't change the number, but we can actually get the largest if we swipe this 2 digit. So that's why we have to swipe 999998, correct? So that time we have to check that if these two what are the number placed at the front or at the left side, and that actually equals to the maximum digit, so I don't need to swipe that. Go to the next. If it is possible, then swipe. Suppose all are actually same, all are 499, then here actually we don't need to call the swipe function, correct? But here actually our number is 4321. This is our number 4321. in this situation 4 is the actually largest number in this number, largest digit. So here actually what should I swipe? Swipe again this place. So ultimately we don't need to call this. So that's why we have to suppose here actually we don't need to call the swipe function, but suppose one example is 4 1 2 3. Okay, so here actually you can check 4 is placed, maximum digit placed at the correct position. Now second largest number is digit is 3, that should be placed at the this position, because I here actually we don't need to call the swipe function. So here actually we call swipe function. So number will be 4 3 2 1. Correct. So for each place, suppose this is our I place, index I. So I have to check that is there any number present at the right side that actually larger than this, then I will call this function. So for 4, is there any number at the right side that is greater than 4? No. So that's why we will not call any swipe function. So next I will go to shift I to the right side 1. Okay, then I will check, is there any digit that is larger than this current value 1? Yes, 3. What is the maximum value? 3. So I will call this swipe function and I will get the output, and I will this will be our actual answer. Correct. I will break from that. And suppose this is clear. Now this is the example 9989. Okay, now for this digit, is there any number at the right side of this that is really greater than 9? No. So I don't need to call this function swipe function. So next go to the actual I here. So 9, for this index I is equal to 1, is there any number at the right side that actually larger than this current number? No. Correct. So again go to the next index I will be shifted to this. Is there any number at the right side of this current position that is greater than 8? Yes, this is actually greater than this. So I'll call the swipe function. So ultimately the output will be 9998. Correct. And I'll break from that. This will be our answer. So for this approach, this brute force approach, what will be the time velocity of this? So for whatever you're doing, first of all, for each index I or each place I am searching. Search, is there any digit present at the range I plus 1 to n that actually greater than nums of I. Correct. For each index I have to find out that at the right side of that I plus 1 to n, range will be I plus 1 to n, is there any digit directly greater than the current digit nums of I that present in the index I. So if I will find out what is the maximum value at the right side, I plus 1 to n in this range, and I will check what is the number present in the current index I. If it is greater than this, so I have to call the swipe. Otherwise I will not call swipe. I will go to the next index I is equal to then I plus plus. Now for this, what will be the time velocity of this? Time velocity will be what? I am actually placing I. What will be the ith range will be 0 to n. Correct. And this range function will call I plus 1 to n. So this will be again big of n. So time velocity ultimately what will be the time velocity big of n square, because this is nested. So this will give us TLE. Correct. This approach is clear. Brute force approach, how it's working, and why did it give us TLE. Correct. Now how can I optimize this? If you understand this brute force approach, then I think optimal approach will be easy for you. So optimal approach what? So any index 99899. Okay. So what I have to do, for each index, for each digit, I'm trying to find that is there any digit present at the right side of that is actually greater than this, or greater than 9. Correct. That we are trying to find. Now if I already calculated that what is the actually so similarly for 8 also, for this index also I am trying to find this, is there any number at the right that is actually greater than this or not. Similarly for 9, this 9. Okay, so now if you already calculated this, what is it actually maximum value till this? How? So first of all, this array length is 4 digit are present. Okay, 4 digit are present. 3, 4. Okay, so this index will be the maximum value is 9. Okay, so for this, what is the maximum value for this range? This will again 9. For this index, what is the maximum value? Maximum value will be 9. You can check actually for this range, what is the maximum value? What will be range? 8, 9, 9. What is the maximum value? It will be 9. Correct. Now for this, again it will be 9 because it itself is a 9. Correct. For this range, what is the maximum value? I calculate this. What is the maximum value present at the right of each range? Here actually range is n-1 to n-1. Here actually range is n-2 to n-1. Okay, here it will be actually this will be 0 to n-1, and this is content 0 to n-1, this is content 1 to n-1, this is content 2 to n-1, this is content 3 to n-1. You can check all of this range actually content what is the maximum value present from this range 0 to n-1, then this content 1 to n-1. Okay, this content this in one pass actually I can actually suffix here actually I can actually calculate this what is the maximum value present at the right side till now, and inject if I actually traverse this right to left, then actually I can actually get the value. Now I have this array. Okay, calculate the value. Now what I have to do, next step is I will iterate this array, this input array. Okay, now left to right actually iterate. What is the current value here? 9. What is the maximum value for the I plus 1 to n-1? I plus 1 will be what? 1 to n-1. This range, what is the maximum value? 9. This is again 9. Correct. So do I need to call the swipe function? No, because the current value is also 9 and maximum value present the right of this, that is also 9. You can check this range is also content 9, so I don't need to call the swipe. Now go to the next index. Next index is 8. Value is 8. And what is the I plus 1 to n-1? I plus 1 will be this in I is equal to 1. So I plus 1 to n-1 will be 2 to n-1. So this range. So this will give the ultimate answer. What is the maximum value present at the 2 to n-1? So what is the maximum value present at the here actually 9. Okay. So here actually what you can check the value present at the current index here actually 8, and maximum value present at the right of this is 9. So I need to call the swipe function. This will give the actually maximum answer, maximum number. So if I swipe this, here actually multiple 9 actually present at the right. So which index should I actually swipe this? I have to store that. I will call this swipe function this rightmost 9. Correct. Rightmost 9. That will give the, you can say actually if I swipe this 9, 8, 9, 9, if I swipe these two, suppose both are actually 9, 9. So our answer will be 9, 9, 8, 9. Okay. And if I swipe these two number, see these two digit, then the answer will be 9, 9, 8, 999, 8. So you can say what is the largest? This will be the largest. So that's why I have to swipe the rightmost 9, or whatever the rightmost actually value of position. I have to swipe that position. So that's why here actually we call the swipe function, and I will break from here. Intuition clear? How I actually optimize the actually from brute force approach to this approach. So here actually you are calculating the maximum value present on the right side of any index like I to n-1. So here actually in one pass actually you can actually calculate this. The time will be big of n, and space constraint for it will be big of n because we are creating a new array. Now for this approach, for this second step, what actually doing? We have already calculated this. Now we are again iterating this input array. So time will be big of n. Here we are trying to find what is actually maximum value present at the right. From this here actually we will easily find out this particularly. So again time will be big of n. So ultimately total time will be big of n, and space constraint will be big of n because we have created an array for the this calculate the maximum value at the present at the I plus 1 to n. Correct. Now go to the actual code, it will be more easy to understand. So first I will convert the input number into string. Why? To easily access the index value. That's why. You can also convert the array also, but it will be easy to convert the string. So now n is equal to s dot size. I will get the what is the input number, how many actually digits are present. Now write of n. Here actually what I calculate, I am actually calculating the what is the maximum value present at this 0 to n minus 1, then 1 to n minus 1 in this way, correct? So write of n minus 1, it will store the index of n minus 1. Index, I am storing the index. Here actually we need actually finally ultimately need the index, correct? Why actually need the index? Because I have to swipe that ultimately. So I need to know the what is the position I have to swipe. Okay. Finally we need to know the position. So that's why I'm position initially this rightmost position is storing n minus 1. Okay. And now I'm traversing from right to left. I is equal to n minus 2 to I greater than equal to 0, I plus plus. I am checking whatever the value present at the s dot ith index. If it is less than the right value, right of I plus 1. Okay. This is the I. Okay. This is the I. Suppose 9989. Okay. So this actually store 1 2 3. This will store 0 1 2 3. This is store 3. Now I will starting iterating from here. I is equal to 2. So I will 2. What is the value of this 8? If it is less than the right of I plus 1, right of I plus 1, what? Right of I plus 1, right of I plus 1, right of I plus 1, I plus 1 give actually 3. And this is the right array. So right I plus 1 actually what is stored? Index 3. So s dot 3, what is the value which will ultimately store? 9. And s dot I, it will give the value 8. So if 8 less than equal to 9, then what will store? This already this is current number is smaller than the rightmost right number I have seen till now. Maximum number I have seen till now in the right side. So I'll just assign that index. Right of I will store that particular index. It will also store the index 3. Okay, that third index I have seen the maximum value till now. Okay, now else means what? Here shall we go to the next. Else means suppose this is your number 998. Okay, so initially our right array, what will store actually? This will store 3. So now I will start iterate from this index I is equal to 2. Now what is the current value? Current value is 9. It is greater than next number I have seen till now 8. Yes, it is greater than this. So now our maximum number will be 9. So what will be the index of this? Current index is 2. So that's why if it is greater, current number is 9 greater than 8, then I will just assign the current index. So it will store the current index because it itself is the maximum number till now. That's why I write I is equal to I. It is clear? I have already calculated this for 9899. I have calculated this, the index of this. So it will store first 3, then it will again store 3, it will again 3, and this is actually 3. Okay, this is actually right array. After this operation, this for loop, the right array look like this. Okay, now what I have to do? I have to iterate the input array. I will check whatever the number present here, and what is the number present? Is there any number present at the right side of that index that is greater than this? Then I have to call the swipe function, correct? So that's why I'm just iterating I is equal to 0, I less than n minus 1. Why n minus 1? Because last index doesn't affect anything, because after there is no element at the right side. So it is larger or smaller, there is not care, right? So that's why I less than n minus 1. Last index we are actually removing this. So if current index is 9, okay, here for this array, current index is 9, value is 9, and s right of I plus 1. I plus 1, what is it store? It store I plus 1, 3. So 3 value is what? S of 3. S of 3, it will what will it return? S of return 9. So 9 less than 9? No. So you don't need to call the swipe. So again go to the next index. Next index is 8. next int is 1, our value is 8. And s of right of I plus 1. Right of I plus 1 means what? This is right of I plus 1, 3. And s of 3 will be again give us 9. So 8 less than 9. Yes, it is true. So I will come to this if block. So I have to call this swipe function. So what actually is swipe? I will swipe these two rightmost. This is, you can check, I have stored the rightmost position of 9, not these two. 9 actually there is 2 9 at the right side, but I have stored only the rightmost 9. Correct. So that's why I will swipe these two position. You can check c is equal to si and si is equal to s right of I plus 1. That means current index s dot I, it will actually ultimately now, what actual number was 9899. So in c I have stored 8. Okay, now I have actually replaced this with 9. Correct, I have replaced this with 9. Si is equal to s right of I plus 1. Now this particular index, this index will be replaced with 8. c store 8. Correct. And then break from here, because I can actually call maximum one time this swipe function. I have already swiped one time, so just break from here. Correct. And at the end, this string is that I modified, this string is, I have to return this, and in return I have to return the integer type. So I just convert this into the integer is to I, string to integer, and input string I will return this. So I will return 9998. Clear? It is clear. If you any doubt, you can comment on that, and if you have any suggestion, you can also comment on for that. And if the explanation is clear for you, please like the video. If you not yet subscribed, please subscribe the channel. Okay, and I have already discussed the time student space complexity for this approach. Correct. Okay.